morning, students. In the last class, we discussed about what is a signal, what is system, how many types of the signals are there, how many types of the systems are there, and classification of signals and systems. And we are doing some problems. Okay, so already we started the problems. Some 3 or 4 problems we have done yesterday. So if you see the next problem, test the following systems for time invariant y of n equal to n into x square of n. Y of n equal to n into x square of n. So time invariant system. Time invariant system means it doesn't depend upon its time. Okay. Time invariant system means it depends upon the time only. Okay, so if we take y of n equal to n into x square of n, so if you write y of n minus k is equal to, it become n into x square of n minus k. It is not equal to x of n minus k. So the given system is time variant system. It depends upon the time. That's why it is not a time invariant system. It is a time variant system. The next we will see the test whether the following signal is periodic or not. If if it is periodic, find the fundamental period. Find the fundamental period. Fundamental period means t. We have to find out the value of capital T. Okay. See, so the given problem is sine root 2 pi t. See, it is in the form of sine omega naught t. Sine omega naught t. What is the condition for the signal is a periodic signal? It has to satisfy the condition x of n is equal to x of n plus n. Is it not? X of or n plus t. X of n plus t. So let we take x of t equal to sine root 2 into pi t, which is equated to sine omega naught t. Sine omega naught t. Okay. So omega naught t is root 2 into pi. We can write omega naught as 2 pi f. 2 pi f. So 2 pi f equal to root 2 into pi. Or we can write f as 1 by t. So 2 pi by t is equal to root 2 into pi. This pi and this pi gets cancelled. So we can write t as 2 by root 2. 2 by root 2. So t equal to 2 by root 2, or 2 is equal to t into root 2, or t is equal to 2 by root 2. So this is the period. This is the period of the fundamental period of the given problem. Okay. Next, coming to the next one, test whether the following signal is periodic or not. If periodic, find the fundamental period. Same, it is like the above problem. It is like the above problem. See, it is given as a sine 20 pi t plus sine 5 pi t. So we will write this as sine omega 1 t plus sine omega 2 t. We will find the fundamental time period separately. Okay. So omega 1 equal to 20 into pi. Here omega 2 equal to 5 into pi. Okay. So omega 1 can be written as 2 pi f1. 2 pi f1 equal to 20 pi. Okay, or 2 pi by t is equal to 20 pi. Okay, so pi gets cancelled. 2 pi by t1 equal to 20 pi, or t1 equal to 2 by 10, that is 1 by 10, is equal to 0.1. So here first fundamental time period t1 is 0.1 seconds. Similarly, omega 2 is equated to 5 pi, or omega 2 can be written as 2 pi f2. 2 pi f2 or 2 pi by t2 is equal to 5 pi. So 2 pi by tt is equal to 5 pi. 5 pi gets cancelled. So tt equal to 2 by 5 or 0.4. So this is the fundamental period of the second fundamental period. So by the definition of the time period, t is equal to t1 by t2, or it is 0.1 by 0.4, it is equal to 0.25. So the total fundamental period of the this problem is 0.25. Okay. Next, coming to the invertibility or inverse system. Invertibility or inverse system. This is also called as inverse system. How can we say that the system is said to be invertible? So we can generate the input signal x of n from the output of a system y of n. Here, x, if you see the diagram, x of n is the input signal, omega n is the output signal. Okay, so the inverse system, omega n can be obtained from x of n. So we can generate the input signal x of n from the output of the system y of n. So output of the system y of n. So from omega n to x of n can be generated. So that we take the system h of n and the inverse system h inverse of n. Okay, h of n is the original system, its inverse system is h inverse of n. So the output of the system h of n can be connected to the input of the inverse system. Here these two are connected in cascaded manner. So its output is omega n. Okay, right. It can generate it by using cascading of inverse system with the original system. Here h of n is the original system, h inverse of n is the its inverse system. So these two are initially connected in a cascaded manner. Okay, cascaded manner. It can be represented like this. So x of n is input of the system h of n, y of n is its output, and inverse system. The y of n is also represented as input of the inverse system, and omega of n is nothing but its output. Okay, right. Omega n can be represented as y of n, that is nothing but the input of the inverse system, y of n convolved with h inverse of n. Okay, similarly y of n can be represented as x of n convolved with h of n. So this y of n can be represented as x of n convolved with x of n convolved with h of n whole convolved with h inverse of n. Okay, right. Now we can write this as x of n convolved with h of n convolved with h inverse of n. So h of n convolved with h inverse of n will get 1. So it is x of n, right? So x of n can be generated from the output of the system y of n. But this is called invertibility or inverse system. Inverse system. Okay. So from omega of n, x of n can be generated. Okay. Now we'll see the determine the convolution of two sequences. What is meant by convolution? Convolution. How to represent this convolution? Convolution is nothing but see the convolution definition. For linear time invariant system with the input sequence x of n and impulse response h of n, h of n are given, we can find the output y of n by using the equation y of n is equal to sigma k equal to minus infinity to infinity x of k into h of n minus k. This is the mathematical representation of our convolution, or we can write this as y of n equal to x of n convolved with h of n, where the star represents the convolution operation. Okay, right. So we'll see the this is the definition of the convolution, and we will see the simple problem regarding the convolution. Okay, so it is defined as the output response or response or output signal h of n or y of n. Output response is y of n can be obtained by using the formula sigma k equal to minus infinity to infinity x of k into h of n minus k. Sigma k equal to minus infinity to infinity x of k into h of n minus k. This is the definition of convolution. Then now we will see the problem. Determine the convolution of two sequences. Here, two sequences are given. X of n is 3 to 1 2, h of n equal to 1 to 1 2. 1 to 1 comma 2 comma 1 comma 2 comma. Here the arrow mark is given at 2. It means that h of 0 is 2, h of minus 1 is 1, h of 1 is 1, h of 2 is 2. Right here there is no arrow mark given. It means that x of 0 is 3, x of 1 is 2, x of 2 is 1, and x of 3 is 2. So these are the two sequences. First of all, we will find the length of the sequences. See here, four components are there. In this one, four components are there. We can write this as x of k is equal to 3 to 1 2. So this length of the sequence is 4. That is uh, represented as n1. N1, the length of the sequence is represented as n1 for the first set. Coming to the second one, here the length of the sequence is also 4. That is represented as n2. Okay, so the total output sequence is by adding these two sequences n1 plus n2 minus 1. N1 plus n2 is how much? 4 plus 4, 8, minus 1, that is 7. So total output sequence, that is the resultant sequence, is 7. So here the sequence number is 4, here its sequence number is 4. 4 plus 4 minus 1 is total output sequence. Okay, next coming to the n1. N1 is 0. 0 means it is started at here. It is started at here means it is 0. And N2 is started at here, but arrow mark is at here, but it starts from here. It means that it is minus 1, right? It is 0, it is minus 1, it is plus 1, it is plus 2, right? It is minus 1. That's why N2 is minus 1. So N1 plus N2 is 0 plus minus 1, that is minus 1. Okay, N1 plus N2 is minus 1. Okay, right. Now we will draw the graphical representation of the first sequence and graphical representation of the second sequence. X of t is at 0 it is 3, at 1 it is 2, at 2 its value is 1, and at 3 its value is 2. Similarly, at minus 1 its value is 1, at 0 its value is 2, at 1 its value is 1, and at 2 its value is 2. So what is the formula for finding the convolution of the two sequences? That is y of n is equal to sigma k equal to minus infinity to infinity x of k into h of n minus k, right? See here, the total output sequence is n1 plus n2 minus 1, that is 7. So we have 7 elements. Okay, k is minus infinity infinity means we have 7 elements. So y of n equal to k equal to, but when it will start? It will start from minus 1, right? Minus 1. It will start from minus 1. So minus 1. So it is minus 1, 0, 1. Here see minus 1, 0, 1, 2, and 1, 2, 3. Okay. So we'll start, or we'll substitute the values of n here. If k is minus 1, k is minus 1, then k is minus 1, then x of k and h of n minus infinity infinity means is we have 7 elements, minus infinity infinity. Okay, we'll take 7 elements, 1, 2, 3, 4, 5, 6, 7, right? So it starts from minus 1, not from 0. We will take two sequences, so minus 1, 0, 1, 2, 3, 4, 5, like that. We will take 7. It starts from minus 1 and take 7 elements. Okay, so k equal to minus 1 to 5, x of k into h of n minus k. Okay, so for n equal to minus 1, so y of minus 1 becomes sigma x of k into h of minus 1 minus k. Already x of k is there. We have to find out h of minus 1 minus k. So here it is a time shifting property. We will use the time shifting property, but by using straightforward method, we can find out this one. By using straightforward method, how to use the straightforward method? H of minus 1 minus k. First of all, h of, so here we will take 5 points as references, A, B, C, D, like that. Okay, suppose Suppose if it is h of minus 1 minus k equal to minus 1, then minus 1 minus k equal to minus 1 minus k equal to minus 1 plus 1, or k equal to 0. So first one is 0. At 0 its value is 1. So like that we will represent at 0 its value is 1. Similarly, minus 1 minus k equal to 0. Okay, so minus 1 minus k equal to 0, minus k equal to minus 1, or k equal to minus k equal to 0, minus common, if we take minus is common, minus of 1 plus k equal to 0, k equal to minus 1. So at minus 1 its value is 2. Similarly, minus 1 minus k equal to 1, or minus 1 minus k equal to 1. If we take minus as common, minus of 1 plus k equal to 1, okay, uh, minus 1 plus k equal to 1, like that, we will draw this graph. So this is h of minus 1 minus k. So this h of minus 1 minus k and x of k, these two can be multiplied. At 0 its value is 3, at 0 its value is 1. So 3 into 1, 3. At 1 its value is 2, at 1 there is no value, so its value is 0. At 2 its value is 1, at 2 there is no value, so its value is 0. At 3 it is 2, at 3 there is no value, so it is 1 into 3, its value is 3. Like that we will find out various graphs and values for these values. So if it is 0, y is 0, sigma of x of k into h of minus k. So n is 0, 0 minus k, minus k. So draw the graph for minus k, h of minus k. Okay, by using straightforward method only. Like that we will get the y of 0 value 6 plus 2 equal to 8. Next, y of, if it is 1, if it is 1, y of 1 equal to x of k into h of 1 minus k. Well, by using time shifting property and straightforward method. Time shifting property and straightforward method. Okay, like that we will find out the value of y of 1 is 8. Similarly, y of 2 is 12, y of 3 is 9, y of 4 is 4, y of 5 is 4. So finally, y of n is 3, 8, 8, 12, 9, 4, and 4. Right? This is the solution for the above problem. Okay. So you may get little bit confusion. Listen to me carefully. So determine the convolution of two sequences. Two sequences are given initially. So first of all, we have to find out the length of the sequence. So first sequence length and second sequence length we have to find out, right? After that, total output sequence length is obtained by using n1 plus n2 minus 1, that is 4 plus 4 minus 1, that is 7, right? 7, right? After that, from where it is started, from where the set 1 is started, where the set 2 is started, from which value it is starting. It is starting from 0, it is starting from minus 1. So 0 minus 1 minus 1. So our resultant values are also started from minus 1 to 7 numbers. So minus 1, 0, 1, 2, 3, 1, 2, 3, 5 numbers plus 4 and 5, like that. So at these values we will find out the y of n, values. Okay, so x of k multiplied by h of n minus k, so that we will get the different values for these values, these different values. Okay, so that we will get the output sequence as 3, 8, 8, 12, 9, 4 and 4. Okay, right, it clear? Next, we will see the convolution sum of two sequences. So the convolution sum of two sequences can be found by using the following steps. So step 1 is choose an initial value of n, the starting time for evaluating the output sequence y of n if x of n starts at n equal to n1 and h of n starts at n equal to n2, then n equal to n plus n2 is a considerable choice. Okay, already we have observed in the above problem. N1 plus N2 equal to 0 minus 1, that is minus 1, right? Next, step 2 is express both sequences in terms of index k. So instead of n, we'll replace n by k. Step 3 is hold h of k about k equal to 0 to obtain h of minus k, and shift by n to the right if n is positive, and shift by n uh, if n is negative to obtain h of n minus k. That is nothing but we are using straightforward method. By using straightforward method, we will get any value. Okay, if it is h of minus k, or h of 1 minus k, or h of 2 minus k, or h of minus 1 minus k, or minus 2 minus k, like that. And step 4 is multiply the two sequences x of k and h of n minus k element by element, and sum of the products to get y of n. That was there in the formula. Okay, and step 5 is increment the index n, shift the sequence h of n minus k to right by one sample, and do step 4. Okay, and step 6 is repeat step 5 until the sum of products is 0 for all the remaining values of n. Okay, so these are the 5 steps to do the addition of the two sequences. Okay, by using convolution. Next, properties of convolution. Coming to the properties of convolution. Okay, properties of convolution. These are all the properties of convolution. See the properties. First property. So here we have the 3 or 4 properties of convolution are there. First one is cumulative law. Commutative law. How to define or how to represent this commutative law? So it is x of n convolved with h of n is equal to h of n convolved with x of n. This is called commutative law. Next one is associative law. That is x of n convolved with h1 of n whole convolved with h2 of n will become x of n convolved with h1 of n convolved with h2 of n. h1 of n convolved with h2 of n whole convolved with x of n. So this is associative law. And third one is distributive law. X of n convolved with h1 of n plus h2 of n whole is equal to x of n convolved with h1 of n plus x of n convolved with h2 of n. These are the three basic convolution properties. What are they? Commutative law, associative law, and distributive law. Commutative law is x of n convolved with h of n is equal to h of n convolved with x of n. Similarly, associative law is x of n convolved with h1 of n whole convolved with h2 of n can be written as x of n convolved with the whole of h1 of n convolved with h2 of n. Similarly, distributive law can be represented as x of n convolved with the whole of h1 of n plus h2 of n is equal to x of n convolved with h1 of n plus x of n convolved with h2 of n. Right? So these are the three basic properties of convolution. Now we will see the problem. Find the convolution of two sequences x1 x of n equal to 1 2 1 1 and h of n equal to 1 minus 1 1 minus 1. Right? See, this is x of 0 is 1, x of minus 1 is 2, x of minus 2 is 1, and x of 1 is 1. Similarly, h of n, h of 0 is 1, h of 1 is minus 1, h of 2 is 1, and h of 2 h of 1 h of 3 is minus 1. So what is the length of the sequence here? So here the length of the sequence is 4. Here also the length of the sequence is 4. Total length will get 4 plus 4 minus 1. So that is 7. And it starts from minus 2 here. And it starts from 0 here. So small n1 is minus 2 and small n2 is 0. By adding these two, minus 2 plus 0 minus 2. So it starts from minus 2 to 7 numbers. Okay, k is minus 2, minus 1, 0, minus 2, minus 1, 0, 1, 2, 3, 4. Okay, 1, 2, 3, 4. See here, right? So like the same problem, So x of k is first is minus 2. First value x of k value is the k value is minus 2. After that minus 1. After that 0. After that 1. After that 2. After that 3. After that 4. Right? So what is the formula for finding the convolution? Y of n equal to sigma k equal to minus infinity infinity x of k into h of n minus k. Okay, if k is or n is minus 2, then it will become x of k into h of minus 2 minus k. Okay, minus 2 minus k, right? So first of all we'll take minus 2 minus k. See here, this is minus 2 minus k, right? So like straightforward method, we will find the values of these minus 2 minus 1 0 and 1, so that you will get the values like this by multiplying x of k and with h of n minus k. We will get these values. Okay, like that we will find out the values from minus 2 to plus 4. So we will get the sequence y of n equal to 1 1 0 1 minus 2 0 minus 1, and we'll put the arrow at here. Why? Because we'll get 0 at x of 0. X of 0 is 0. Okay, so let's see the last step. See the last step here. Repeat step until the sum of products is 0 for all the remaining values of n. So we'll put the arrow at there. Okay, right? In the above problem, there is no 0. We get, that's why we didn't put any arrow here. Okay, right? So wherever you get 0 value, we'll put arrow at there. Okay, so practice it. So you may get a little bit confusion, so you practice 1 to 2 times, so that it will become clear for you. Okay, so this is the convolution problem. So the formula for finding the convolution is y of n equals sigma k is minus infinity infinity x of k into h of n minus k. Okay, right. Okay, is it clear? Okay, so with this, I will conclude the today's class, and the next class we will see the jet transforms. Just to go through this class, if you have any doubts, you may ask by WhatsApp or by attending the class. Okay, thank you.